that we've got a backup as well. Okay, so it's recording. So whenever you want to get going, you can.
Sure. So my name is Kaurov. I am a postdoctoral IBM fellow at the Institute for Advanced Study at Princeton, New Jersey, in the United States. So I have a PhD in astronomy and astrophysics, and my main research is astronomy and astrophysics. But recently I got interested in VR and what we can do there. My original thought was that we can use VR for doing science. I think it's not the case right now. It's not there yet, but for outreach, for scientific outreach, it's perfect. So now I want to tell you why I think so. The first is like this simple slide, which shows the locations of like 180 displays or planetariums around the world. And as you can see in this slide, in the United States, it's not that bad. In Japan is amazing. They have like the planetariums on every step. But there are continents where there are almost no planetariums. And obviously planetariums are not accessible because of that for the majority of children around the world. They are not cheap because you have admissions, and on top of that you have transportation. And even if you live in New York, you have like the very famous planetarium on Manhattan. But if you see how often high school kids attend planetarium, it's at the best once a year, or usually it's like once in a lifetime. And also it requires schedulings. It's usually group trips with school, with camps, etc. So it's complicated. And potentially VR can solve this problem. So we can install them easily at local schools, at libraries, at small museums in small cities. So potentially it sounds like a good idea for us. So what we are doing in that direction. So we have two single user experiences that I will talk about, and one multi-user experience that we are developing. I will start with single user experiences. The first one is motivated by like very old movie made in the United States. It's 10-minute movie. We will not watch the whole one. Now I need to pull this YouTube video. Let's see if it works for everyone. Okay. So this video has a very simple concept. Each 10 seconds it zooms out.
This square is a kilometer wide, 1,000 meters.
It zooms out, and in a few seconds we will see the whole Earth. Then we can see solar system.
A fringe of a myriad colors.
Then our galaxy,
in the hand of the sleeping
and
man at
the universe. And the second part of the movie is that it goes back in and shows cells,
quantum motion is a swarm of
DNA, atoms, etc. So this is a very old movie, and it was made in '77. And
now we come upon the two inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus. So massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. 6 neutrons. We are in the domain of universal. We are in the domain of universal modules. There are protons and neutrons in every nucleus.
Can you hear me?
Electrons in every atom. Atoms
yes.
bonded into every molecule out to the farthest galaxy.
Yeah, so I just lost tracking.
As a single proton fills our sea.
Anyway, so I'm back here. Yeah, so this was kind of inspirational video for many people of the generation, and it seems like a very interesting concept to reproduce in the VR.
Together, it was 10 to the 40th.
Yes, now let me
1 and 40 zeros.
Put it away. Oops. Okay, it's on that side of the room. Yeah, so we actually recreating this whole thing in VR, and I will just show you what we have now. And so we are aiming for Oculus Quest because for the reason I mentioned, its price and accessibility to make it easy for distribution in local libraries. And this is a short video showing like what you see in Oculus Quest. It's the interesting thing that we have now, in contrast to 77, is that now we can make everything data driven. We have all actual data from the telescopes, from microscopes, so we can make everything very accurate.
Near the lakeside in Chicago is the start of a breezy afternoon.
Yeah, so now it will just zoom to the virus and bacteria, then to molecules.
Now every 10 seconds we will look from 10 times
and that's it. And also in this experience you can find different objects at different scales and compare them together. For example, here you can see it compares LHC with an object that was recently found by New Horizons satellite, not satellite, spacecraft, and you can compare it with other celestial objects. Anyway, so this one of the projects that we're doing, and here we have this spacecraft, and you can look at it together with an elephant and just get some idea how big are these things in space. So this is one of the things that we are doing. Let me throw it away. And the second project is more about biology. We look at, I will also show you a video. Here we can look at,
but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit.
Here we can look at the assembly of a virus. So the capsid of the virus, so nowadays, like in the news, you can hear about coronavirus all the time. So this virus is actually similar to coronavirus.
The orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the Sun, followed by the massive outer planets, swinging wide in their
Okay, I'm back. I think I have some problems with internet connection because sometimes I'm in, sometimes I'm out. Problem is that now I cannot see my slides for some reason, so I'll be.
Oh, you can't? Okay.
Yes, I cannot see them, but probably you still can.
Yeah, we can still see everything. Are the slides pinned up on the wall? So when you refresh that, you won't have to put them back in?
No, they're not pinned up.
Okay.
Okay, you can watch this video and I will be back in a second.
Okay, yeah.
1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now.
Okay, I'm back here. So now I still cannot see the slides, but I can see the video, so it's strange. Anyway, so in this video you just see how you can assemble a virus, and the idea behind this project was that is there something that we can do in VR that you cannot do on iPad? And this sort of gameplay is hard to imagine on an iPad. So, yeah, so this was the idea. So let me now remove this video.
Time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk.
Yes, and now I will quickly talk about our last project with multi-user experience. I will not show you the slide because I cannot see the slide myself, but I will try to pull in the space a couple of models.
Do you want me to switch the slides to the next one?
I don't remember which one's the next.
Okay. Okay, so I won't move it.
We pause to start back home. This lonely scene, the galaxy's like dust, is what most of space looks like. This emptiness is normal. The richness of our own neighborhood is the exception. The trip back to the picnic on the lakefront will be a sped-up version, reducing the distance to the Earth's surface by 1 power of
Okay,
10
so
every 2 seconds.
just to tell you what else we are doing, in Azil hubs, in this sort of space, we want to try to do remote planetarium lectures, in a sense that we have a lecture somewhere in a remote space at the university, and a bunch of children, we assume those will be children mostly, in some remote school or anywhere else. And the great thing about hubs is that we can pull up different models. We can create easily own real spaces. So, for example, this room was created specifically for this project. So this is a real space that exists in institute in Japan, in Tokyo. It's Earth Life Science Institute, where people study like how life formed in the universe. And the first planetarium show that we develop right now will start in this room, and lecture will talk about what kind of space missions we have, etc. And then we will talk about this particular asteroid. So this asteroid is about a kilometer in diameter, so it's relatively small. And there is a Japanese mission which will land on this asteroid at some point, grab some material, and return it back. And return is planned to the end of 2020, like around the end of 2020. And for that time, we are trying to build up different media coverage, including one in virtual reality. So we have models prepared. So for example, this model is optimized well enough that I can look at in Quest, and it's relatively smooth. I think it's like even, yeah, it looks quite nice. And the lecturer can talk about this asteroid, then plan to have another scene like this, but on the surface of the asteroid. Oops, I think someone pulled something big into the space, and now my Quest cannot handle it. Okay, but now it works. I don't know. Yeah, so this asteroid, and also I want to show you.
As we draw toward the atom's attracting center, we enter upon a vast inner space.
Another thing. Yeah, so this is the asteroid.
So massive and so small.
And for example, lecturer can take a model of a spacecraft and explain each individual part. We can make the copies of this spacecraft thanks to the functionality of Azila hubs, and we can distribute this spacecraft among the different students, etc. So most of the functionalities that we need for this kind of lectures already exists in hubs, and given it's open source, it's much easier to use it in academic environment, in a sense that universities and institutes are not afraid to use it. Yeah, so that's a great thing about Mozilla Hub. Anyway, so that was the last thing that I wanted to talk about. So I will be happy to hear what's your opinion about these things. For us, the big question now is distribution, is how to, whether we want to sell it or provide it for free, and it depends a lot of kind of funding we will be able to get. But for this multi-user experience, it looks like Mozilla Hubs is like literally the only option we have to easily implement this multi-user experience. Yeah, so that's it. Thank you for coming.
Thank you so much. This is really cool that you can bring in and like an example of an asteroid here with this 3D model, and then the spaceship as well.
And our field of view will be 10 times wider.
Yeah,
Mhm.
so
I have a question.
yeah, sure.
Is there a way you can constrain where people can move? Let's say the asteroid, can you constrain it so it only moves like within a certain XYZ coordinate system, like within the table, or so it doesn't fall off the table, or within the room, or that sort of
You
thing?
can pin the objects to where they can move them.
Not at the moment, I don't believe. You could create a spawner so you could have like an original that sits on the table and then everyone can take their own if they wanted in Spoke using like, yeah, Spoke Environment Editor, but you couldn't constrain that object to a table at the moment. It's possible with some of the scripting things we're going to add in the future that could be something that could be programmed in, but yeah, not with the way that Hubs currently exists.
Oh, that's good. Yeah, and also I would need to have multiple objects like strung together so that you would have like a collection moving around.
Mm-hmm. Yeah, that also would be something that maybe with the future scripting stuff that we're going to be doing, but that's not something that's available quite yet. But that would be really cool to be able to have them connected somehow.
Yeah, fantastic. Yeah, and then lastly, if there was a way you could, let's say, have some kind of scripting where you have a path for these things to go on, where you could see like multiple things coming together, falling apart, and then have some kind of audio narrative or visual narrative something behind it, or so everything's all moving together like on a stage or something.
Yeah, I don't know. So we have similar problem in a sense. We want to add some animation to the satellites as some parts are coming off, etc. And for that, I think currently we can only put these animations into GLB file and just import the whole model with animation.
Mm-hmm.
I think that's the only solution right now.
Yeah, that's good enough for now. So, because my point is that you want to see like everything moving around each other.
Yeah.
So there's a path for it to go in. Okay.
Yeah. So currently we plan to do it like with an animation that inside this GLB file, but also lecturer can just like show it like this, and it would be good enough, I think.
Mm-hmm.
And maybe it will be even more fun.
Oh, cool.
That's really cool. As someone who grew up somewhere very small that had no access to a planetarium or many big like natural museums, this is a really exciting project that you're working on.
Thank you.
Did anyone else have any questions?
Okay. Yeah, thank you again for coming. And I don't know, we can hang out in this room more.
I definitely have a few more questions for you, but I wanted to like open it up to anyone else if they were trying to unmute or something. But I wanted to know more about like kind of what are some of the other like next steps or like other sorts of like, because right now you've got this environment. Are there other social like environments that you're kind of thinking about designing in the future?
Yeah, so for this particular experience, we want to do it with JAXA. It's a Japanese analog of NASA, and they planned this mission and everything. And the timing is great because it's coming in a few months back to Earth. So creating something specifically for this event seems to be like very interesting. And the environment that we will build, everything will start in this room. Then it will be surface of the asteroid, like a specific spot where the thing landed.
Oh, cool.
And the third space will be even more interesting, maybe. So this asteroid was named Ryugu. I cannot pronounce it in Japanese, obviously. So this is a place from a Japanese fairy tale. So some undersea kingdom where like magic things live. Anyway, so it would be interesting to recreate something like that space, and also tell like a little bit about this fairy tale. So we plan like real rooms and surface on the asteroid and something from a fairy tale. So maybe like this diversity would be very interesting and something that you really cannot create in a planetarium.
Mm-hmm.
Yes, so for us is like the main project that we want to do in Mozilla Hubs in the next few months. And yes, if it will be successful, and I really hope that it will be successful, and I think there is every reason for it to be successful, then we can try to think to do something outside of astronomy. Actually, this is we do astronomy first because that's my background. But it would be fun to do same thing for biology, etc. So any science can be communicated this way.
That's really cool. Can I get a photo of you holding the asteroid?
Of course.
Awesome. It's counting down from 3 now.
Yeah, I tried to smile like stupid.
I saw a presentation, or there was the presentation yesterday. Someone was talking about like art galleries and being able to give tours of art galleries to people from all around the world, and being able to bring in like world-class experts to be able to talk about it. And that seems like this has a lot of potential for that as well, to be able to have people who are super knowledgeable, but who maybe can't travel to a location to be able to teach classes of people about it, rather than having just like a non-expert giving these sorts of lectures. So that's
yes,
really cool.
Yes, so that's very important, and there are many places where you cannot bring experts to.
Yeah.
For example, I try to talk with people who do different stuff in Africa, like education in Africa. I ask them whether they think it can be cool. They said that it's definitely cool, but they don't have money to do it for obvious reasons. They have more, that they have different priorities. But what they told me is that if you have headsets and software, then potentially they have all of the resources to bring these headsets to local schools. Like to find local IT person who can connect them to Wi-Fi, etc. So potentially it's also doable to do this kind of outreach in countries where you don't have experts at all. And another option is another interesting place to explore, which I'm doing right now, is children's hospitals. Because there, for example, if you want to do outreach in a hospital, you need to go through different kinds of checks. You need to do like a lot of shots, etc., just to get access to the kids who hospitalized for like months or even years sometimes. So if you do this kind of thing, then it's much easier to bring an expert to those kids and have something like personal interaction with them.
That's really cool.
There are many things that I'm trying to explore right now.
Well, thank you so much for your time and for telling us about that. And I'm definitely very keen to hear more about the work that you folks are doing. So as you move forward, please share it with us in the Hubs Discord, because this is really exciting.
Of course, yes, and I will certainly ask you many questions, and and I think I'll find a couple of bugs. Like
I'm sure that you will. Yeah, if you've got any questions or anything, you can just pop into the Discord, and like the dev team is like super accessible and stuff. And it was nice that you were able to come by and meet some of the team on our Friday meetup last week.
Sure. Yeah, thank you a lot.
All right, I've got to get going, so I'm going to stop the recording now.